Hello again, higher algebra students, back here with lesson 1 of unit 10, manipulating polynomials. So we're going to just get introduced here to the polynomial and look at some things, evaluating and adding, subtracting, multiplying, and so forth. So those are our objectives here to try and get through these 4 in this lesson. So first of all, again, what's a polynomial? One or more variables, okay? So, and it uses the operations of really addition, subtraction, multiplication. And the exponents are positive whole numbers. So for instance, when you look at something like this, that would mean that's not a polynomial. Or even look at something like this, where it's 7 divided by x, so that would not be a polynomial. These two here on the left side would both be polynomials. Obviously, this has an exponent of 1, so that's a whole number exponent, as is this one right here. So, and this would be what's called a third degree polynomial we'll talk about here shortly. So the degree of the polynomial is the value of the largest exponent. So again, it's not always in order. Again, I could rewrite this particular question or this particular polynomial like this. Either way, it's a second degree polynomial because the largest exponent with our variable x here is a 2. If the largest exponent is a 3, then it's a third degree polynomial and so on. So as we look at these, we're basically looking for, again, at the exponents. We have a 6, a 5, and a 2 here. 6 is obviously the biggest, so this would be a 6th degree polynomial. Here, again, we have a 3 and a 4, but the 4 is the bigger one, so that would naturally be a 4th degree. Here you can see a 5th degree and an 8th degree here. So you just got to make sure you look through all the exponents. Obviously, 7 is a pretty big exponent, but again, because there was one that was bigger than it, that would be an 8th degree polynomial. So evaluating these polynomials is really the idea of if this polynomial here is a function x, or this one's a function x, again, this value here is what goes in for x in each spot. So what we do here is we would take this -2 and we'd put it in a parenthesis every time. And again, the reason we're putting it in a parenthesis is for a couple reasons. First, for instance, if you were to type in -2 to the 6th on your calculator, what's going to happen is that will, if you don't have a parenthesis, that will return a negative value. But -2 to the 6th is really -2 times -2 times -2 times -2 times -2 times -2. So 2 times 2 is 4, times -2 is a -8, times a -2 is a positive 16, times a -2 is a -32, times a -2 is a positive 64. Okay, so again, if you don't put a parenthesis here, this will return a -64 on your calculator when this was actually 64. Okay, now again, to the 5th was right here, which was the -32. So even though we have a parenthesis on this one, because it's raised to an odd number exponent, that will actually end up being negative. So this ends up actually being +3 times a -32 there. And again, parentheses and exponents come first when we're talking about order of operations. -5, and then again, -2 squared, which is just 4, and then +4. Okay, so we've got 64 plus a negative, or minus 96. This again here is going to be 5 times 4. -2 squared is 4 up here, so that would be -20, and then +4. Okay, you add or subtract all those up, and you get a -48. So the value of this function, when we evaluate it at x equals -2, is going to equal -48. Similarly down here, I'll switch colors here. So f of 4 just means any place there was an x, we put a 4 in the parentheses. So 4 to the 3rd minus 4 to the 4th plus 7 times 4 minus 2. So again, 4 to the 3rd is 4 times 4 times 4, which is 64. Okay. 4 to the 4th is then 256. So this would actually be minus 256 because that's 64 times 4. These three were 64 times 4. And again, it was a minus out front, and so that would stay a minus there. Plus 7 times 4, so plus 28, minus 2. So you take all those, you add them up, 64 minus 256 plus 28 minus 2, and that gives you a value of negative 166 when we evaluate this function at x equals 4. Then technically you could say f of 4 equals that, or you may see y equals negative 166 there. All right, now the standard form of a polynomial, which we'll start to talk about standard form and eventually factored form with these polynomials, but the standard form of a polynomial is where you put the highest degree first. So it's the way we're most used to. So you can see, for instance, when you look at this polynomial here, this is a 6th degree polynomial, and that biggest exponent is in the last term as we look at it. So to write it in standard form, what you're going to do is just rearrange from biggest exponent to smallest exponent. Now you got to just be mindful. This was a minus 7 here, so it still has to be a minus 7 there. All the rest were plus, and again, including the x to the 6th, so that's a positive x to the 6th. And rearranging that puts it in standard form. So as we look at this first one here, it's negative 2x to the 6th is what would be considered the leading term here with the 6th degree polynomial. And then we have a positive 7x to the 3rd and a positive 3x and a positive 9. Okay, so the negative again just got carried out front, or that minus got carried out front to be a negative, which we read the same way in this situation. This wouldn't change if we were to evaluate at a certain x. Our answer would naturally be the same for both of these because we didn't change the polynomial, we just rearranged it into standard form. So another one here, just as an example, you can see positive 4x to the 3rd is the biggest degree, minus 12x squared still is the next biggest, a positive 5x, that's plus 5x, and then minus 8 as we rewrite that in standard form. Now, adding and subtracting polynomials, this brings a kind of another angle, and we won't run through every example here, but I'll just kind of look at the top one for each of these. And so what you're looking at here is you just have to be very mindful of this operation, the fact that it's a plus here, because what that allows is for us to really take this and rewrite it as 5x to the 3rd minus 6x squared plus x, and then it's plus 2x, so we can write, or 2x to the 3rd, I should say. It's plus a negative 7x, that's just minus 7x, and then plus a 3, okay? So now we rewrote it, and it looks just like a string of values where we need to combine like terms now rather than two polynomials. And so when we combine like terms here, what we have is 5x cubed and 2x cubed gives us 7x cubed. We have negative 6x squared is the only x squared term. Okay, we have a positive x and a negative 7x, that would be a minus 6x. And then we had that plus 3 at the end. So again, we're just combining those like terms and getting that final polynomial. So again, same sort of thing here. We could rewrite this basically with just taking out these parentheses and rewriting this whole function as is. Again, because it's a plus, that's already built into here. So the difference with the subtraction is you have to keep in mind this is technically like a minus 1, and then that changes the sign of all these. So if you look at the idea of distributing here, what we really have is if we want to take these parentheses out, we have the 3x cubed minus 9x squared plus 4x, but then we have a negative 2x cubed right here. So this is minus 2x cubed, okay? Again, that's just carrying the minus through. Well, then we had minus a negative 6x squared. So minus a negative is actually plus, which is really the idea of distributing a negative 1 to this makes it a positive. So that's 6x squared. And then again, a negative here, this negative out front, distribute out to a positive 5 means that turns into a minus 5. So again, we combine like terms. We have 3x cubed and a negative 2x cubed, which just leaves us with x cubed, or 1x cubed if you want to write that. We have a negative 9x squared and a positive 6x squared. So there's minus 3x squared. And then we had a positive 4x. and a minus 5. So same thing here as on the bottom. As we have this first part, we can kind of take the parentheses off of that. But again, what we're doing is because this minus carries out to everything, that means we would write this as minus 3x to the fourth minus a negative x cubed right here means this is going to be plus x cubed. Minus 7x means that just stays minus 7x. And then minus a negative 9 means that turns into a positive 9. And then again, we just combine the like terms. And then naturally you can combine like terms here. So we have the x to the fourth term here and here to be combined for a negative 2x to the fourth. We have 9x to the third and x to the third. So there's a total of 10x to the third. There's no x squared terms here, but we do have a negative 3x and a negative 7x. That's negative 10x. And then finally, a plus 7 and a plus 9, again, because it was minus a negative 9 to give us plus 16 at the end there. So, so combining like terms there at the end, again, is just the last step in the subtraction process. All right, so moving forward, just one last idea here with multiplying polynomials. And again, just a reminder, we won't have any negative exponents, we won't have any fractional exponents. You will maybe see these terms like a monomial term, which would just be like x or 3 or, 3x. Might be 6x squared, something like that. Binomial might be x squared minus 5 or x squared plus x. Trinomial would be x squared plus 3x plus 2 or whatever it may be. So, and of course, that goes on to 4 terms, 5 terms, and so on. So when we look at this, one thing you do have to consider is when you add and subtract, terms with exponents are almost like a label. So it's almost like this is 5 apples plus 3 apples. Okay, so give us this 8x squared total. But if they have different exponents, x to the fourth and x to the fifth, then it's almost like this is apples and this is oranges. And so you can't take 2 minus 7 and have it be negative 5 apple oranges or apples or oranges or whatever it happens to be. So what ends up happening here is actually this answer, or the way this was written, is the final answer because you can't combine those like terms. Now that's a little different than multiplication where the exponents don't really play a role. What you're really doing in multiplication is you are going to multiply the numerical values, which in this case would be 5 times 3, and then you're going to multiply the terms with the exponents, which in this case would be x squared times x squared. Now x squared times x squared, again, the big kind of confusion here is, do you multiply the exponents or do you add them? And of course, in this one, it doesn't matter because 2 plus 2 and 2 times 2 are the same. But in general, it is you add the exponents here. And a good way to just check that is take, say, 2 squared times 2 to the third. And does that equal 2 to the fifth or 2 to the sixth? So in other words, is it 2 plus 3 or 2 times 3? Well, 2 to squared is 4. 2 to the third is 8. So that's 4 times 8 is 32. Well, 32 is equal to 2 to the fifth. Okay, so again, you're adding the exponents. So this would be 15x to the fourth here. This one would be 14, 2 times 7. And then x to the ninth, again, because it's 4 plus 5 when it comes to those exponents. So just a reminder down here, you can multiply any degree polynomial by any other degree polynomial, but you can add and subtract different degrees. So a couple last things here. We're used to some of these kind of distributing the 2x. So 2x times negative 2x would be a negative 4x squared, again, because it's x to the 1 and x to the 1, so you add those exponents to get 2. Or 2x times negative 3 is minus 6x. So there's one that we're used to. Here's another one that we're used to where we FOIL. First gives us 8n squared. Outside gives us 4n times 6, which is 24n. Inside 1 times 2n, so that's 2n. And last, which is 1 times 6. And then again, we're going to combine those like terms from the middle, so that would actually be plus 26n plus 6 here. Okay? Now, because in this unit we're spending a lot more time with third degree or higher polynomials, which have 4 or 5 terms perhaps, we're going to look at one here where you multiply where one is a 2 term, a binomial, and one's a 3 term, a trinomial. And when you do this, you have to remember that you're actually multiplying 6 times here because you've got the first term times each of the 3, and then the second term times each of the 3. And if you think if it's a 3 and a 3, now you're multiplying 9 times. If it's a 3 and a 4, you're multiplying 12 times. That can be very difficult to keep track of. When we FOIL, we're so used to just writing out that first, outside, inside, last. But here it can be a little trickier. So one thing you can do is use what's called this area model, which is basically to write these equations as labels, and don't forget where things are added or subtracted. And then from there, you just you can multiply in each box. So for instance, this box right here, 24a to the third, would be that first term times the first term. Okay, 4a times a negative a, or negative 4a squared, would be that first term here times the second term here, and so on. 4a times 2 is 8a. 2 times 6a squared is 12a squared. 2 times a negative a is negative 2a. And 2 times 2 is 4. Okay, so when you're looking at this, now you just have to remember that we have to combine the like terms. Okay, so we've got just the 24a cubed there. Then we've got the a squared terms, and we've got the a terms, and then we've got just the integer at the end. So when you combine these like terms, you see that we've got 24a cubed. We've got a 12a squared and a negative 4a squared, so that's 8a squareds right here. We've got a negative 2a and a positive 8a, so that's 6a's. And then we have the 4 at the end. Okay? And that would be after we combine all the like terms. Now, one last one here is the idea of having a 3 by 3. And again, just a reminder that you can set up, in this case, a 3 by 3 area model. Okay, and so what we have here is we have 6n squared, I'll do this down the side, minus 6n minus 5 down the side. Okay, and then across the top, we'd have the second term here, which is 7n squared plus 6n minus 5. And again, I could put a plus in front of these just to remind myself they're positive. Typically, if you don't put the negative there, then that reminds us. And now we just go through. So this first one here would be 42, because it's 7 times 6, and then n squared times n squared is n to the 4th. Again, it's because it's 2 plus 2. So then we can go down a row here. So we've got 7n squared times negative 6n would be negative 42n to the 3rd. Again, because n to the 1st and n to the 2nd ends up being n to the 3rd. And then we also have 36n to the 3rd right here, which is the 6n squared and the 6n. And then we can go to another set. So we have negative 5 times 7n squared is a negative 35n squared. Negative 6n times 6n is a negative 36n squared. 6n squared times a negative 5 would be a negative 30n squared. So again, we take all those blue terms and add them up. And of course, they ended up all being negative in this case. So we're going to have a big negative n squared term. And then we continue on. 6n times negative 5, this is a negative 30n. Negative 6n times negative 5, that's a positive 30n. I'm just going to put a plus in front of it just to remind myself that that's positive. But again, the plus you don't need to include there. And then negative 5 times negative 5 at the very end means that this is 25 for that last term. And then again, you combine like terms. So you've got the 42n to the 4th. The n cubes would combine to be negative 6n cubed. The n squareds end up being what? Negative 101n squared. And then the n's actually take care of each other. So you won't even have an n term in the end because you have a negative 30n and a positive 30n. And then you add 25 at the end. So that would be multiplying, when you have binomials, trinomials are bigger, so that you can just, again, organize your thoughts about what all do I have to multiply here, and then combine at the end. All right, thank you for listening. As always, if you have questions, please ask.